Hello and welcome to AI Frontiers, the podcast exploring the cutting edge of artificial intelligence research. Today, we're diving deep into the world of information retrieval. We'll be analyzing a selection of recent research papers to uncover the latest trends, methodologies, and breakthroughs in this rapidly evolving field. This episode explores the latest trends in information retrieval, analyzing research papers to uncover key breakthroughs. The focus is on efficient and effective access to relevant knowledge, highlighting the vital role of information retrieval in digital tools and services. Information retrieval, often abbreviated as IR, is the science of searching for information in documents. It encompasses searching for documents themselves and searching for the metadata which describes data. Information retrieval underpins many digital tools like e-commerce search and recommendations. Efficiently accessing relevant knowledge is increasingly important, making information retrieval a foundational technology. Based on our analysis, a key research theme is improving search recall through query expansion and semantic understanding. This involves going beyond simple keyword matching, focusing on understanding user intent for broader results. For example, Thulke et al. Explore semantic query expansion for legal information retrieval, augmenting queries with knowledge graphs and semantic analysis. Another prominent research theme is leveraging large language models, or LLMs, to enhance information retrieval capabilities. Large language models are being used for query understanding and document summarization. The goal is generating more relevant search results directly. Li et al. Use large language models to generate synthetic semantic insights, improving text-to-chart retrieval by bridging the semantic gap. A third research theme revolves around personalization and user modeling, tailoring recommendations to individual preferences. This requires sophisticated techniques for understanding user preferences and tailoring recommendations to specific user needs. Kai et al. Model the life cycle of user interests, aligning recommendations with current user preferences. Several key findings emerge from the analyzed papers. Shang et al. Demonstrate that smaller models can outperform larger ones with sufficient data. Zhang et al. Show that graph-based re-ranking reduces adversarial attacks. Meng et al. Report that generative re-ranking improves e-commerce metrics. Chari et al. Found that Latinized text fine-tuning performs comparably to native text in some settings. These findings showcase impactful results and practical implications in the field. Common methodologies in information retrieval research include knowledge distillation, graph neural networks, contrastive learning, and retrieval augmented generation, or RAG. Knowledge distillation involves training smaller models to mimic larger ones. Graph neural networks, or GNNs, are used for modeling relationships in graphs. Contrastive learning encourages similar examples to be close in the embedding space. Retrieval augmented generation enhances large language models with retrieval. Knowledge distillation is a prevalent technique as shown in the work from Shang et al. Let's examine the paper by Shang et al., which addresses deploying large language models in real-time e-commerce search systems. The objective is to use knowledge distillation to transfer ranking ability to a student model. Augmented training data significantly expands the student model's dataset. The student model ultimately outperforms the teacher model with enough augmented data. The paper by Zhang et al. Addresses the vulnerability of retrieval augmented generation, or RAG, systems to adversarial attacks. To combat this, the authors propose a graph-based re-ranking framework called GRADA. It identifies and filters out adversarial examples using document relationships. GRADA reduces the success rate of attacks with minimal accuracy loss. Kai et al.'s paper focuses on capturing the dynamic nature of user interests in recommendation systems. The authors propose a Deep Interest Lifecycle Network, or DILD. DIL models the emergence, stabilization, and decline of interests. Online A/B testing demonstrates improved click-through and conversion rates. Future directions in information retrieval include continued integration of large language models, a greater focus on fairness and trustworthiness in information retrieval, and the development of more human-centered and adaptive systems. Addressing the scalability of complex models is essential, along with the need for more robust evaluation metrics. Knowledge distillation involves training a small student model to mimic a larger teacher model. This reduces computational cost and latency for deployment. The student must capture the teacher's knowledge and capabilities. Knowledge distillation is particularly important for deploying large language models in resource-constrained environments. It is important to acknowledge that this synthesis was created using AI tools, specifically GPT using Google, using Models, Gemini 2.0 Flash for content generation, TTS synthesis through OpenAI for voiceovers, and image generation using OpenAI for visuals. While reviewed by a human expert, some oversights may exist. All references are provided for further review and analysis. Subscribe to AI Frontiers for the latest AI research. Get in-depth analysis and expert insights. Discover breakthroughs and future trends in the field. Subscribe to our YouTube channel for more in-depth explorations of AI Frontiers. Stay updated on the latest developments in artificial intelligence. Join the community of AI enthusiasts.